right, so if you're looking for the notes, you need to go under Canvas, go to our class, go to modules, go right here to chapter 3, which is at the top, and right here is the notes packet that you need to download to your Google Drive. So go ahead and do that. And this is what you should see. Any more time? All right. So what we're going to be starting on in chapter 3 is solving quadratic equations by graphing using algebra methods, and then we'll be applying what we learn and we'll be solving some real life problems. So when we're solving a quadratic, there's a lot of different names we can give to that. If you're told to find the roots of the quadratic, that's the same thing as solving it. If they say to find the zeros, same thing. X-intercepts, solutions, all of these are the same thing. You're solving the quadratic. The roots of an equation, that is, if you have a root of an equation, that means it's a solution of the quadratic equation. If you have a zero of the function, that's going to be an x value for which f of x equals 0. So the three ways we're going to look at today are by graphing, and that would be finding the x-intercepts of the function that could be written in standard form. We're going to use square roots. So if we have something squared equals d, we can take the square root of both sides and solve that. Or we can write the polynomial equation that's given to us in standard form. We can change it to factored form and then use the zero product property. That's what we're going to be doing. This first problem we want to solve by square roots. It's the easiest way to solve it. So I'm trying to get this by itself. So what would we do? Yep, subtract 1 first. So our goal is to isolate that quadratic right there, that quantity squared. So once I have this quantity squared, to get it by itself, I can take the square root of both sides. Because the square root of a quantity squared is just going to become x plus 3. But what do I have to do when I have an equation and I take the square root? What do I have to put in front of the square root of 4? Plus or minus. Anytime you have an equation and you take a square root, you have to put plus or minus. And then to solve this, I can subtract 3 from both sides. So my solution then, I'm going to have positive 2 minus 3. What's the answer to that? I'm doing positive 2 minus 3, that's negative 1. Or I can do negative 2 minus 3, and what's that going to be? So those are the two solutions that should work. If I'm not sure if I'm correct, let's plug it in. What's negative 1 plus 3? 2. What's 2 squared? Plus 1, is that 5? Plug in negative 5. What's negative 5 plus 3? Negative 2. What's negative 2 squared? Plus 1, is that 5? Yeah, so those are our two solutions. The zero product property. If the product of two expressions is 0, then one or both of the expressions has to be 0. In other words, with algebra, if A times B has to be 0, then either A is 0 or B is 0. That's something we learned a long time ago. If you multiply two numbers and you get an answer of 0, one of the two numbers has to be 0. Yeah?
I think I got the first number question, like the one above.
Okay, if it's a little different, just change it to what I've got, okay? All right. So looking at this one, we have this factor and this factor have to multiply to be 0. So that means that one of these two must be 0. So I'm going to have to do 2x minus 5 could be 0, or x plus 1 could be 0. Solving this one, I'm going to add 5 to both sides. Divide by 2. So one of my solutions then is 5 halves. My other solution, I could subtract 1, and I get negative 1. And so my two solutions then are 5/2 and -1. Those are the two values of x that are going to make that true. I want you to go ahead and turn on your graphing calculator. I want to show you how you can do this on the calculator. I want you to put the left side of the equation in for y sub 1. So I want you to put in 2x minus 5 times x plus 1. Put that in for y sub 1. Into y sub 2, I want you to put in the right side of the equation 0. How do we make it so that all of our screens look the same? Zoom what? So everybody do a zoom 6. If you get an error message, it might be because your stat plots are on. Anybody getting an error message? Okay, good. So we're trying to find where does our function equal 0. So now I can go to second, trace, and I want to find where is this equal to that. So I'm trying to find an intersect point. So I'm going to get close over here, and it says, is blue your first curve? Enter. Is red your second curve? Enter. Enter one more time, and it tells us that one of our answers is -1, which is what we got. For our other answer, I do second, trace, calculate, intersect. We get close over there to the other solution. Is blue the first one? Enter. Is red the second one? Enter. Enter one more time, and 2.5, which is 5/2. So that's a way we can use our calculator to check our answers. Now, what is the difference between this example versus this one? Yeah, this equals 7. Guys, if two numbers multiply to be 7, does one of the numbers have to be 7? No. 2 times 3.5 is 7. 3 times 7/3 is 7. 4 times 7/4 is 7. So I have to do this a different way. Setting each of these equal to 0 only works if that number is 0. If this is anything else, here's what I have to do. I would have to multiply this all out. So x times x is x squared. The outers gives me -2x. The inners gives me +4x. The last times the last gives me -8. And it still equals 7. What did I say we have to get it set equal to? 0. It has to equal 0. So now I'm going to have x squared. What is -2x plus 4x? 2x. And then I have -8 still equal to 7. What did I say it's equal to? We need it. So subtract your 7. And so we have x squared plus 2x minus 15 equals 0. Now I have it set equal to 0, so now I can set up double parentheses. I look here first. What times what gives us x squared? X times x. Now I look here. What numbers multiply to be 15 and subtract to be 2? 3 and 5. And when I check my outers, I get 5x. When I check my inners, I get 3x. And I need to get a +2x. So what do the signs need to be for that to happen? Right, -3, +5. So now I can set each one of these equal to 0. Now we can set them equal to 0. And so what are our solutions going to be then? X is going to equal 3 or those are our two solutions. So this problem, we do not like it when it equals a number besides 0 because we have to go through all of that work to find the solution. All right, let's look at this one. Is this set equal to 0? Get it set equal to 0. So I have to bring the 5 over. It's going to become plus 5. Do you guys remember doing this in Algebra 1, how you solve a problem like this? A lot of people do. Set up your double parentheses. Look here first. What times what gives us 2x squared? 2x and x. Now look here. What numbers multiply to be 5? 1 and 5. Now, I can try putting the 5 here. I could put the 5 here and the 1 here. When I check my outers, I get 2x. When I check my inners, I get 5x. I need to get 11. Are 2 and 5 going to give me 11? No. I can't add them or subtract them and get 11. So I need to change those. So what am I going to do? I don't want it to be 5 and 1. So I must want it to be 1 and 5, right? So now what do I get when I check the outers? 10x. On the inners, what do we get? 1x. Can I add or subtract those and get a positive 11? What do the signs need to be? Positive and positive. If I make it positive and positive, that's going to be what's going to give me that positive 11x that we need. Now we have it set equal to 0 and it's multiplication, so one of those two has to be equal to 0. Finish the problem and I'm going to call on somebody to tell me the final answer. Read, what did you got? Yes, it should be -1/2 or -5. If I wanted to check this, guys, I'm going to do it quick. You don't need to follow along this time. But I could have set this right here, this 2x squared plus 11x. I could have gone back to the beginning, put that in for y1, this into y2. I'm going to graph it. And what would I be looking for then? Not the x-intercepts now. I want to know where does this function equal -5, right? So I do second trace, calculate, intersect, and I'm just going to check this one here, enter, 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 -1/2. Isn't that what we got? That's one of our answers. If I want to check the other one, intersect, get over there close to it, enter, 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 -5 is our other solution. The y values are not solutions, only the x's are. Because I'm saying, where is it that these x's are equal to what it's supposed to be? Okay, go to the next part here. All right, we have to think of the best way to solve these problems, the fastest way to solve. What am I going to do on this kind of problem? What do you think? Square roots. So first I'm going to have to add 19 to both sides. I get 2k plus 3 quantity squared equals, what's 81 plus 19? 100. Okay, go ahead and finish now. Once we have quantity squared, take the square root. Finish, check your answers. You can have them written in either order, it doesn't matter. Okay, questions? Yes, Drew?
This is about the square root of the 2k plus 3 squared. I still see the -2k plus, like, the negative square root answer. for where does the negative answer apply? Like square root of k can't be negative k, or where are we only doing the positive version?
We're not. We're saying that 2k plus 3 is plus or minus 10. I just wrote positive 10 here and negative 10 here. I just split it up instead of writing it as 1 and doing 2k plus 3 equals plus or minus 10. That's really hard to work with because I have to think 10 minus 3 and negative 10 minus 3. So instead of writing the plus or minus 10, I just put the positive 10 here, the negative 10 here. Does that make sense?
Yeah.
Thank you. Okay, number 2. Guys, I do not like to have fractions when I'm going to solve an equation. What can I multiply this whole equation by and get rid of the fact that we have a fraction? 7. Multiply every term by 7. That term, that term, that term. So then we're going to have, what's 1/7 times 7? That's just going to be 1p squared. And then what's 5/7 times 7? 5p squared. And 20 times 7 is 140. All right, so now I would have to subtract 5p squared. Okay, what is this p squared minus 5p squared going to give us? Negative 4p squared, good. Okay, now I'm going to divide by negative 4. So I'm going to have p squared equals, this will not go in, will it go in evenly? Let's see, I can divide 140 by 2 twice. That's why I divide by 4. I don't know 140 divided by 4. 140 divided by 2 is 70, and then divide by 2 again, and what do you get? 35. That's the fastest way to divide by 4, unless you just know it. Okay, now I'm going to take the square root of both sides. Is there a perfect square root of 35? No. So I just have to say p equals, what do I have to put in front? Plus or minus the square root of 35. That's how we have to answer that question. If there's no perfect square root, we just leave it like that. All right, let's have you try this one on your own. Think about what you have to get it set equal to and then solve it. You should be just about finished. If not, look up here. X squared, I look here first. If there's no coefficient, it's just going to go x and x. I can quickly do this. If there's no coefficient, read it backwards. Numbers that multiply to be 40 and add to be 14. What numbers multiply to be 40? 8 and 5, 4 and 10. Which of those add to be 14? 4 and 10. So those are the numbers I use. Now, when I get the outers, I get 10x. Inners are 4x. I'm trying to get negative 14. So what do I want the signs to be? Negative and negative. And then what are the final solutions? 10 and 4. Okay? Always get a set equal to 0 first. All right, let's do this one together. I'm going to get the x squared over, so I'm going to add x squared. I need to get the 4x over because I always want to get it set equal to 0. So now I'm going to have 0 on the right. 5x squared plus x squared, what is that? 6x squared. And then 5x minus 4x is an x. And then I still have the negative 1. This has a coefficient. I can't just quickly say, are there numbers that multiply to be 1 and subtract to be 1? Because there's a coefficient in front of the x squared. So instead, I have to do it this way. I look here first. What are numbers that multiply to be 6x squared? 3 and 2. I'm going to try it. It may work, it may not. Next, I look here. What are numbers that multiply to be 1? 1 and 1. Now we check the outers. The outers give us 3x. The inners give us 2x. With those outers and inners, I'm trying to get a positive 1x. So which of those needs to be positive and which needs to be negative? 3 has to be positive, 2 has to be negative. Here's where the 3's coming from. The 3 has to be positive, the 2 has to be negative. Okay, that's the way you want to think of that. Can you go directly to the answers? Can you think ahead and get them? 1/3 is right. 1/2, do you agree with 1/2? Negative 1/2. Guys, when you do this homework, as I put up here and as I put on Canvas, I should say 3.1, but anyway, you have to do this on notebook paper. We are not going to just have that Canvas book and you just write in the answers. We have to practice factoring. So I want it done on a separate sheet of paper. Okay, number 5. A skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Anybody know how many feet are in a mile? 5,280. This is almost a mile high, which sounds miserable to me. I would hate this. I don't like heights. Use the formula h of t equals negative 16t squared plus h sub o to write an equation that gives the skydiver's height, h, in feet during free fall t seconds after the skydiver drops out of the airplane. You're going to have to do problem 59 on your homework. You're going to have to look back at this formula. This is a formula that always works for free falling objects. So h of t, that means the height at any time is going to be negative 16 times the time squared plus, what do you think h sub o means? It means the starting height. It means the height at time 0. What is the height at time 0? 4624. Okay? Let's see here. What's it say? Use the formula to write an equation that gives the skydiver's height. We got it. That's it. That's all we have to write. This will tell us the height at any given time. All right, well, let's look at this. Is it possible for the skydiver to wait 18 seconds before pulling the parachute cord? What do you guys think? You think he could wait 18 seconds and be okay? No? How could we find out if he is going to be okay doing that? Plug in 18 into this function, so find h of 18. What's that going to tell us? What does h of 18 tell us, you guys? His height at 18 seconds, right? Okay? I'm not even going to, watch how I'm going to do this. I'm not going to plug that into my home screen. I think it's interesting to see this. So I'm going to put in negative 16x squared, and then I'm going to do plus 4624. I'm going to set my window. The time, I'm going to put the time going up to 20. Y is going to be his height. He's starting at 4624. I better make this 5,000. Okay, I want this x max to go out to 20 because we're going to test 18 seconds. So now I'm going to hit graph. So here's where he starts. This is going to be his height at any given time. Where can I go to just quickly see 18? Table, there's a place I can go. I don't feel like scrolling. I'm going to do this instead. I'm going to do second trace, calculate a value when x is 18. There's his height. Is that going to be okay? What does that mean? Where's he going to be? Below the ground, yeah. So obviously not. No, definitely not. Yeah, he's gonna be under the ground. Has anybody ever I don't know if it's skydived or skydove. Okay, me neither. I have a friend who's done it. I'm just wondering, like, there has to be some certain height above ground where you want to, you know what I mean? So, like, if we looked at this table, maybe it's, I don't know, 1,000 feet or something. So at 15 seconds, he'd be pretty safe. You see what I'm saying? That would be his height. Okay. Find and interpret h of 1 minus h of 2. Well, I can look at my table, right? H of 1 is 4608 minus h of 2 is 4560. You guys see where I'm getting that? The height at time 1 and the height at 2. Go to your home screen. 4608 minus 4560 is 48. What is that telling me? The distance he fell between
1 and 2 seconds.
Right. Distance fallen between 1 second and 2 seconds. Okay. And that's it for the notes. Just a quick reminder again, do this on a separate sheet of paper. Okay? Yeah.
So, schedule from one side, but we need 17 seconds, 5,000 feet.
Hold on just a second. What's that again?
Between 3 and 5,000 feet there is when they want to move.
Is that right? Wow. So if it's 3,000, between 3 and 5,000, that's good data. So he could, so even as soon as he jumped out, he could theoretically do it?
Once he's there,
You said 3,000 to 5,000?
3,000 to 5,000, somewhere down there.
So the last he could do it would be like after 10 seconds then. Okay, cool. That's great to know. Okay guys, that's it for today. Make sure you practice this factoring and solving of the quadratics.